we have to solve for the angle of twist. So we know that we are applying this equation to solve for the angle of twist. And therefore, the angle of twist for gear A is equal to the algebraic sum of the torque times the length over the polar moment times the modulus of elasticity. And that which we know has to be taken from torque for point AC, length for AC over the polar moment times the modulus of elasticity. That is a constant, plus torque at CD, length at CD over the polar moment times the modulus of elasticity. These are constant because the material has not changed, and therefore the value for polar moment and G remain the same, plus torque at DE, length at DE over polar moment and modulus of elasticity. Therefore, we substitute the value. The torque at AC was 150 Newton meter. The length for AC is 0.4 meter. This is the length for AC, and that's the torque which we got. And I move to CD. The torque for CD is minus 130 Newton meter, and the length for that section is 0.3 meter. I have 0.3 meter. And of course, we know the polar moment value is gotten from this formula. Polar moment equal to what? Equal to pi over 2c to the power 4. And this c is some kind of a radius. And therefore, that polar moment, pi over 2, and we look at the shaft diameter, is 14 millimeter. You divide this by 2. 14 divided by 2, you get the radius. And that is going to be 7 millimeter. So if I convert that to meter, I'm going to have 0.007 meter. And if I multiply that to the power 4, I'm going to have 3,771 times 10 to the power minus 9 meter to the power 4. And this value for the modulus of elasticity is 80 GPa. And that must be converted to the right unit. We're going to have 8 times 10 to the power 9 Newton per meter square. And that is the same for this, because the shaft has the same material and the same modulus of elasticity. So the torque at TDE is minus 17 Newton meter, and the length for that section is 0.5 meter. And therefore, the angle of twist at A for the gear is minus 0.2121 rads. We know deflection is negative, and therefore displacement SP equal to the deflection of A times arrow. And we know this deflection is negative, and therefore we are going to have negative, negative, we are going to have positive 0.2121 times 100 millimeter, and this is in rad, and that will become what? That will become 21.2 millimeter, and that is the displacement. And you see how we are able to solve for the displacement, and that is how we solve for the displacement. So thank you very much.